we are covering decimals, and we're going to do like rounding with decimals, order of operations with decimals, solving equations with decimals, using formulas with decimals. So it's a lot of old ideas that we've already covered: rounding, PEMDAS, solving equations, using formulas. Now the only difference is we're going to have decimals involved. And again, just like with fractions, I'm going to let you just use your calculator. I cannot teach you all of decimals by hand in one day. It's just not going to happen. So if you have a calculator, go grab it, get it out. Preferably the same calculator you're going to use on the day of the test. Use that now so you can practice with it. And again, if you're having any trouble with your calculators, drop into office hours or shoot me an email with your model number, and I can Google the model number of your calculator and give you some pointers. But I'll be using my TI calculator that's in the syllabus, so I can show my camera and demonstrate if you need some help today. But we're going to cover decimals, and we're going to start with rounding. So the rules for rounding are exactly the same as the rules for rounding whole numbers. The difference is we have more place values now because we're doing decimal numbers. So I have a little place value chart here. Some things we're missing, because normally when we're face-to-face, I have y'all in groups and you fill all this out, but we're going to do it together. So your decimal point is going to separate your whole numbers. That's what we've been doing so far, from the decimal numbers. Okay. And when you read a decimal, we use the word "and" for that. Okay. And then again, to the left of the decimal, you have your ones place, tens place, hundreds place, thousands place. To the right of your decimal, you're going to have tenths place. And then I don't know why this space is so small, but this would be your hundredths. So it's 100, TH, hundredths place. So make sure you're reading really carefully on MyMathLab. Are they asking you to round to the nearest hundred or hundredths with a TH on there? So read really carefully. I've noticed sometimes students get questions wrong on the final because everything's mixed up on the final, and they'll misread hundreds to be hundredths or vice versa. Okay, so read really carefully. Then you have your thousandths place. Then it would be your 10,000ths place, and so on. 100,000ths, then you'd have millionths if you were going there. Okay, so you have to know your place values. So we're going to practice reading some numbers here. Oh, and then there's the fractional values are missing there. We don't really need to know that, but a tenth would be 1/10. And the reason why we're doing this is to emphasize that fractions and decimals are related. You can take a fraction and write it as a decimal number. Not all decimal numbers can be written as fractions, but all fractions can be written as decimal numbers. So if I did 1/10 in my calculator, if you do 1 divided by 10 in your calculator, you're going to get the number 0.1. 1 in the tenths place. If I did 1 divided by 100 in my calculator, I'd get the decimal number 0.01. There'd be a 1 in the hundredths place, and so on. So 1,000th, 1/10,000th, 100,000th, and so on. Okay, so I wanted to practice writing out some numbers here, and we were just going to practice reading them. So, oh, poop. Oh, man. I hit the eraser button. That's okay. I forgot I'm not in my app. I'm on Blackboard, and it erases everything. Who thought that was a good idea? Like, who thought up the eraser button should erase everything? Okay, anyway. So what if I gave us this number? Let's say I have this number right here. So the way you would read this is you'd say 32 and 5/100ths. So this would be, I'd read this as 5/100ths. Okay. What if I had this number? So here's the thing that students say in everyday English. We would probably read this 302, right? But the word and is specifically going to be reserved for that decimal. So I would just have to read this 302 with no and in it, 302. And then I have the word 21 there. 21, and the 1 would be in the thousandths place. And you're going to get a lot of practice with writing these numbers out and reading these numbers out later in the notes and also in my math lab. But I just wanted to kind of dust some cobwebs off because we don't deal with reading and writing these numbers very often, right? Like, and very few of us actually write checks and things anymore where you might do it in real life. So I just wanted to dust some cobwebs off. We're going to start with rounding though. So let's just do that. Let's go into some rounding questions. And again, this page was missing on the notes if you printed it out, but we're just going to practice rounding to different decimal places. So let's start here with 3. It says round the following to the nearest dollar. Nearest dollar. So if they say nearest dollar, that's your ones place. They call it a units place, nearest dollar. So I'm going to underline where my nearest dollar would be. To the nearest dollar. If you have $58.82, that 82 cents tips you up to $59. There you go. Yeah, $59. If you have $1.29, 29 cents is less than half a dollar. So yeah, that's just going to come out to be $1. And usually students get these right on my math lab, no problem. And then they get down to C and it's like, if you have 43 cents, but you're being asked to round to the nearest dollar, you only have 2 choices. Yeah, either it's closer to $0 or it's closer to $1. And it's so hard for our brain to say $0 because you actually physically have money there, but you're going to round it down to $0 because 43 cents is less than half a dollar, so you don't round it up. Okay, so you're going to follow the rules of math even if it seems weird and wrong. You're just going to do it. Okay, they could also ask you to round money to the nearest dime, which implies the tenths place. So if they say the dime, that's the number after the decimal point. So I'm going to underline the tenths place, and I'll let you go ahead and round those real quick. Ooh, I see 2 different answers there for A. It's tricky, right? So tenths place. So this is how we're going to round. These are our rules. Oh, you're conceding Corey's right. Yeah. So remember your rule. You locate the place value. It said tenths place. So I locate the tenths place. You look behind it. Since 2 is less than 5, I don't bump it up. So yeah, it's going to be $19.30. And then, but here, when I look behind the 6, oh, that's funny. Corey was going to agree with you. So the rule for rounding, remember, whatever place value you're telling you to round, you locate that number. Either that number is going to stay the same or that number is going to bump up. The way you decide is you look behind it. Yeah, so this one's going to bump up. So that's going to be 3.7, and then you turn everything else to a 0. Same thing with this 2. It's in the tenths place. It's either going to stay a 2 or it's going to bump up. When I look behind it, there's a 6. Yeah, so it's going to bump it up. There you go. And most times, y'all, if you're dealing with money, we're going to deal a lot with money in the next class. If you're dealing with money and they don't tell you how to round, if there's no fine print telling you how to round, you're always going to round to the nearest penny, which is the hundredths place. So you'll locate the digit in the hundredths place and then you'll round. So this 2 is either going to stay the same or bump up, but because there's a 1 behind it, it's going to stay the same. So that would be approximately 82 cents. So you'll get this long decimal number on your calculator, and if they don't tell you how to round, you round to the nearest hundredth by default. So the next one, that 9 is either going to bump up or stay the same, but it's going to stay the same because there's a 3. Yeah. and so on. So there's really nothing different here. The only difference is reading the place values. Here, the 6 is going to bump up because there's an 8 behind it. Yeah, so it'd be 57 cents. And the 0 that you write in front of the decimal is optional. I personally like to write it, but MyMathLab will count it right either way. Your calculator won't. Most calculators won't include a 0 in front, but I like to put it because it helps me see the decimal point better. So, but it's totally optional. Okay, so a little bit more about rounding. Okay, so you're going to see rounding built into word problems, and I'm just going to do 2 of them with you because, like I said before, there's going to be what you would do in real life, and then there's going to be like the mathematical thing to do. And MyMathLab is a computer, so you're going to do the mathematical thing to do, not what you would do in real life, right? So here's a problem from MyMathLab. It says you purchase 3.25 pounds of apples at $1.47 per pound. When you use your calculator to multiply the numbers, you get this number, but how much do you actually pay? Does it tell me how to round? Yeah, you have 2 options there. Yeah, I see all kinds of answers. Someone's like, you would in real life would say, oh, we need to give a $5 bill or something, right? Or you would round, you might say, oh, it was like close to 475, or like you might say something colloquial like in real life. But for math, if they do not tell you how to round it, you're going to have to round to the nearest penny. You have to know that, or MyMathLab will count it wrong. Yeah, so the nearest penny is the hundredths place. So you have to be really exact down to the nearest penny. So here's your hundredths place. You would look behind it, and then since 7 is bigger than 5, you'd bump that up 1. So in MyMathLab, you're going to enter 4.78. That's how much you're going to pay. Even though your calculator gave you something weird and MyMathLab didn't tell you how to round, you're going to have to know round it to the nearest penny and enter that in MyMathLab. And in this section, if you get a question wrong for rounding, I will not override the score for you because this decimal rounding is going to come up so much in the next the next class that I really want you to practice it. Like on previous MyMathLab homeworks, when you made a rounding error, you could email me and I'd override the score. I'm not going to do that for day 6, just so you know, because you really got to get rounding down with decimals. Okay, here's another example of one that's different than what we would do in real life. But it's on MyMathLab, right? So are we in real life? No, we're in MyMathLab. So let's look at this one. It says the items in your grocery cart are listed below. Round each to the nearest dollar. So you have to do that first. And estimate how much your groceries will cost. So you have to round them to the nearest dollar. And then you'll add them all up, right? So let's look at bananas here. If I round that to the nearest dollar, I'm going to get $1. Okay, then we go to bread. $2.87. That's going to round up to $3. Then we go to eggs. $2.19. That's going to round down to $2 and keep going. Got milk. $5.99. That's going to round up to $6. And then we have our cereal. $5.24. And one more. We got cheese going on over here. Cheese. I love cheese. Okay. So to get it right on MyMathLab, you have to round first. Then you're going to go add all those rounded numbers up and see what you get. So let's see. That's going to be 14, 15, 16, 17, 18, 19. Was that 19? But in real life, you probably don't want to do that, right? If you did that in real life, you might end up with not enough money to pay. In real life, you'd probably round everything up to overestimate. So like you'd make sure you have enough money, or you would just find the exact answer, right? So it says, is your estimate higher or lower than the actual cost? So let's find the actual cost. Add up all those decimal numbers. So I'll give you a second to type them in on your calculator. Okay. When I added them all up in my calculator, I got, 19.77. So $19.77. So my estimate was too low. So in real life, rounding to the nearest dollar isn't that great for money in this situation, right? Because there's smaller amounts of money, so you want to round more carefully. So a better strategy might be to, instead of rounding to the nearest dollar, maybe round to the 10th. To the nearest dime might be better. Oh, I should write it out this. Maybe round to the nearest 10th would be better. Or maybe just find the exact answer, right? To make sure you have enough money. But the more carefully you round, the closer your estimate would be to the actual amount. So, or if you rounded to the nearest penny, then it'd be the exact amount. All of these are to the nearest penny, right? So, but rounding to the nearest 10th might be a better strategy. Just rounding to the nearest dollar kind of rounded the numbers too much, basically. But anyway, I just wanted to point it out because when you're working problems in MyMathLab, you're going to be like, that doesn't make sense. So you might just add them all up and then rounds, and you would get the answer wrong. Because let's look at that. If I added all the numbers up on my calculator, and then I rounded that to the nearest dollar, I would have entered $20 into my MyMathLab, and my MyMathLab would have counted it wrong. And then you'd get all frustrated. You'd be like, did I not round correctly? It's because you didn't follow what my MyMathLab wanted. My MyMathLab wanted you to round first, then add them to get the estimate. So I just want to say it right now so you don't get frustrated on your homework. Any questions on that? Why I had to round first? Yeah, so that's going to be $6 regardless. Like no matter what you do. That's a good question, Corey. Corey was asking like $5.99. If I round it to the nearest 10th, that 9's going to round up and still make it $6. So that one's not going to make a difference. I just mainly wanted to warn you that what we would do in real life is get the actual cost and then round it. And if you do that on MyMathLab, it'll count it wrong. Sometimes you'll luck out and get it right anyway. But sometimes it'll count it wrong, and I didn't want you to get frustrated over the weekend. Any other questions or comments on this one before we take a different look at decimals here? Feeling good? Okay. So I was going to have you practice a couple more just to see, because sometimes you don't know like what questions to ask till you mess up. So I'm going to give you one. I'm going to be quiet, and then I'm going to have you all type answers on the screen here. So you weigh a piece of chicken. The scale reads 3.53 ounces. And for A, you're going to round to the nearest ounce. And for B, the nearest 10th of an ounce. And when I say go, I just want you to type your answers there so I can see how you're doing. Okay, go ahead and type your answers on the screen, and we'll see how they come out here. Or you can write if you want. Use the type tool or the writing tool. Type them somewhere on the screen. And remember, it's anonymous when you type on the screen. I won't know who's writing what. Cool. Okay, so it seems like everyone found that to the nearest ounce, it'd be 4 ounces. To the nearest 10th of an ounce, it'd be 3.5. And on MyMathLab, you can enter 3.5, or you can do, 3.50. It should count either of those correct. Technically, you don't need this 0 there. So technically, 3.5 is more simplified, but you could also enter 3.500000 if you wanted to. Those zeros on the end don't count. Okay. If you did not get that one right, I'm going to pause for a second to see if you have any questions. You can raise your hand if you're typing, so I'll know to pause. Oh, okay. I'm going to have you try another one here in a word problem. It says your doctor prescribes a medication for you. According to your personal information, the doctor should give you a prescription for 0.128 milligrams. The pills are available in tenths of milligrams. Round the prescription strength to the nearest tenth of a milligram to determine the correct dosage. So I'm going to go ahead and give you a minute So the nearest tenth of a milligram. Okay, go ahead and type your answers on the screen. Okay, so far the votes are for 0.100, 0.1, 0.100 again. Yep. All those are correct. Ooh, I'm glad someone wrote this right here. Not sure who this was. I know in some countries, for the decimal point, they use like a comma, but in MyMathLab, it's programmed for like the US default, so you have to do the decimal point or it'll count it wrong. So just heads up on that. Oops, wow. My screen went crazy with that one there. Okay. Yeah, but all these are correct. You could have also written, you could type in 0.1, you could type in 0.10, you could type in 0.100. MyMathLab will count it right. You could even put 10 zeros on the end. MyMathLab should count it right. Okay, cool. So this table is just practicing how to read the decimal number aloud a couple of times. I'm not going to spend too much time on this because on MyMathLab, they don't have it's multiple choice. You can just pick out the right wording. And we kind of already talked about the wording a little bit. And on the final, like I never remember them having you write out decimal words because we don't do it very often. But I don't know. Let's not be lazy. Let's do a couple of these. Okay. So the first row's already been done for you, but this next one, if I was going to read that out loud, we would just say 0.3. All right, 0.3. If anyone asks you what that was, you say 0.3. But mathematically, we would say that is either you can say it's 3/10. Oops. You can say it's 3/10. You don't have to say 0 and 3/10, but you could if you wanted to. If you wanted to say 0 and 3/10, you could, but you can just say 3/10. And you could write that as 3 out of 10, 3/10. That's how you would write that fraction. And the next one says 5 and, that's your decimal, 5 and 31 hundredths. 31 hundredths. So you'd write your place values out, tenths, hundredths, and the 31 is going to go in the hundredths place. 31, the 1 goes in the hundredths place. 5 and 31 hundredths. And this next one's weird. So try to write this as a decimal. I'm just going to give you a second. It's 203 10,000ths. 203 10,000ths. Okay, so let's see. There's no whole number part. Oh, and the fraction on this one, I didn't even write out here, would be 5 would be your whole number. And then you would just write 31 hundredths. Now this one, there is no whole number, so it's a 0 in front of the decimal. So it's 0 and 203 10,000. So you have to count your place values out. Tenths, hundredths, thousandths, 10,000ths. This is the 10,000ths place. So no whole number, so I put a 0 in front of the decimal. I have to go to the 10,000ths place. So that 3 is going to go in the 10,000ths place. And then you fill in the numbers from there. And if there's any extra place values between the decimal and that number you wrote, you fill it in with an extra 0. Oh, that's right, Corey. I just saw yours in the tab. So that would be 0 and 203 10,000ths. Or you just read it 203 10,000ths. Just say it that way. So I would write it out as 203. Don't say 203 because the and is a decimal. 203 10,000ths. But like I said, in real life, are you ever going to write these decimal numbers out? Probably not. Oh, you just use your calculator. Oh, good call, Corey. Corey for the win. Yeah, Corey, how did you do your calculator? I think I know what you did, but I'm just curious, how did you do it? You plugged it in as a fraction and changed it to a decimal? That's totally right. You could also do this. I didn't even think about it. Remember, fractions are division, top number divided by bottom number. So if you do 203, hit your division button, and then type in 10,000 and hit your equal button, it'll change it to the decimal number. Yeah, Emma, some calculators are automatically programmed to default to decimals and some aren't. Usually if you use a fraction button, so if I typed in 203 and then my fraction button, 10,000, my calculator will keep it as a fraction. But if I type in, instead of the fraction button, if I do the division button, you know, where it says add, subtract, multiply, divide, if I use a division button, it'll default to a decimal. Emma, do on your do 203 division button 10,000 and see if it gives you the decimal.
It still came up as a fraction.
Oh, what kind of calculator do you have? Is it a Casio?
Not the one that you had said to get during class. I remember that.
Okay, do you have a button on your calculator somewhere that looks like this? It'll say F to D or something like that. Do you see that anywhere?
No, but then I should probably just get that one then. Okay.
No, just if you show me your screen, when we go into breakout groups later, just share your screen and show me your calculator, because I bet I can find the button. Every calculator has some kind of button that changes a fraction to a decimal. If you have a Casio, I don't have that. You have a Casio. It has a button. I can show you. I just don't have that one memorized. But if I see your calculator, I'll tell you what to press. On Casio, I think it says S to D. Do you see a button that says?
I have that one. I have S to D, yes.
Okay, press that, and it should change your. I don't know why, but it should change your fraction to a decimal.
Oh, okay. Hold on. Okay, yeah, it changed it. Thank you.
Yeah, I don't know why Casio does that, and I have no idea what S stands for, but most calculators say fraction to decimal, decimal to fraction. It'll go, so if I type 0.5 and then, so if you type 0.5 and then you press that button, it should change it to 1/2, or if you type 1/2 and you press that button, it should change it back to 0.5 for you. Okay, cool. So let me go share that thing again. The Casio does some really cool other things though, so Casios are pretty cool to have. Hold on, there it goes. Okay, we got a couple more things to talk about before we jump into the fun stuff, which is order of operations and all that. Okay. Oh, yeah, multiplying powers of 10. The reality is, guys, on these MyMathLab homework questions, or if you see it on test, you're just going to use your calculator, right? The reality is, if I ask you to do this decimal times 10, you put it in your calculator and you get the answer. Like in real life, that's what we do. But I wanted to point this one out because, right, Lauren, like no one's going to do this by hand. I'm right there with you. But I wanted to point out this power of 10 thing, because this is the great thing about decimals. Decimal numbers are so slick, y'all, because we have a base 10 number system. So every place value is a power of 10. But it's so slick that we forget how it works sometimes, because it's just so, like, we've done it so long and we forget the ins and outs. But I wanted to point this one little, not trick out, but one pattern out here. If you multiply by 10, all it does is it makes your original number bigger one place value. So see how you could push the decimal back one spot? So let me write a little bigger here. If I have 6.125 and I times by 10, all I do is I push the decimal back one place value and my answer becomes 61.25. If I multiply by 100, you just push the decimal back 2 place values. So if I times by 100, I'd push it back 1, 2 place values, and I would end up getting 612.5, and so on. And the reason why I'm pointing this out is in the next class we do percentages. Percent is a number out of 100, but there's this 10% trick where you just move the decimal around, and it's this idea of if you multiply by a power of 10 and pushes your decimal towards the right, and the opposite is if you divide by a power of 10, it pushes your decimal the other direction. And if you don't want to memorize this now, that's totally okay. You can use your calculator. But when you divide by 10, if I start with 12.5 and I divide by 10, dividing by 10 pushes that decimal 1 place value to the right. Yeah, and you just look at how many zeros. That's right, Rachel. And it tells you how many times to move the decimal. And it's just a shortcut to help us with percentages later. So I just wanted to point it out. But if you don't want to do it, if you just want to use your calculator, that's totally fine too. So like Rachel was saying, if I wanted to divide by 1,000, since there's 3 zeros in 1,000, I'd push my decimal place over 1, 2, 3 times and fill in the blank. So it's a nice little nifty trick that'll help you later on just to like shortcut percentages. But if you don't understand that and you just want to use a calculator, that's okay too. I just wanted to point it out since it popped up on one of the homework questions. Okay. Graphing. Oh my goodness, graphing. Yeah, these are fun. So you could be asked to compare decimal numbers on a number line. And luckily on MyMathLab, it'll be multiple choice, right? So you'll just pick it out, multiple choice. But I wanted to just emphasize a little bit about negative decimals. So we're going to practice graphing these on a number line. You'll get to pick them out multiple choice on MyMathLab, so it won't be quite as tricky. But here we go. Okay, so I'm going to schedule a number line here. And then here's 0. Here's 1, here's 2, and so on. Here's -1, here's -2, -3, and so on. So just sketch a little number line out. Now, it's asking you to graph these two numbers. They're negative. So it's -1 and 2/10, -1 and 3/10. So let's graph -1.2 first. So I'm going to go to my -1 here, but it's -1 and a little more. So I don't know, I'm just going to plot it right there. This might be -1.2. But then -1.3 is a little bit more negative. It's a little bit past that one. So -1.3 is a little bit more negative, so it's a little bit more to the left. So you'll pick out the multiple choice where those are graphed correctly, but then it wants you to place your symbols between them, right? So if I was comparing positive 1.2 to positive 1.3, I would eat the positive 1.3, right? But if I'm comparing -1.2 to -1.3, yeah, it's reversed. It flip-flops it. If -1.3, this is more negative, the one to the left is less. So the 1.3 is less, the 1.2 is more. So this one is going to be more. The closer to 0 you are on the negative side, the bigger you are. So yeah, it flips your sign around. So most of the time on MyMathLab, students pick the correct number line and then they go to place the inequality sign and they flip-flop it. So just be really careful. The number farther to the left is less. So think left, less, left, less. They both have L's. Farther to the left, less. And here, we're not going to graph this next one because it's silly, but this one's easier to compare. See how much easier it is to compare when they're positive? If I have 3.64 that's positive and I'm comparing it to 3.68 that's positive, having $3.64 is less than having $3.68. So it's much easier to compare when it's positive, but when it's negative, you really have to slow your brain down and say, okay, which one's farther to the left on the number line? That one's going to be less.
So I wanted to point that out. I know it's just kind of like a hodgepodge, and I'm kind of skipping around in the notes. So if you printed them out, I'm hitting the highlight reel so we can spend most of our class time on order of operations and equations. So you have to order them. Oh, and square roots. That's right. Okay, here we go. Square roots. All you have to know about a square root is that it's a number on your calculator. It's a button on your calculator somewhere. So square root button. So let's see. Give me a status or a thumbs up or something if you know where your square root button is on the calculator. So give me a happy face or a thumbs up if you know where the square root button is. Okay, so if you don't know where the square root button is, it's probably a second function. Guess some other people know. Okay. Yeah, if you don't know where it is, when we get into breakout groups, raise your hand and I'll come help you. You can turn your screen on. I can help you find it. But all you have to know is how to put it in your calculator. But my math lab is going to ask you some questions, so I didn't want you to get thrown off here. It's going to ask you which two whole numbers is it between? And if you click the help tools, it's going to give you this long explanation of what square roots are. All you have to do is straight up put that in your calculator. So put that number in your calculator and get the decimal. So I'm typing that in my calculator. And I get 3.74165, and so on. So what two whole numbers is it between? It's between 3 and 4. Now, what my math lab is going to say is it's between 3 because 3 squared is 9, and it's 4 because 4 squared is 16, and it's going to say, oh, isn't 14 between 9 and 16? Yes, it is, and it's going to give this long explanation, but all you're going to do is use a calculator, and you're going to be okay. I just didn't want you to get bogged down in the help tools. So which one of those is 14 closer to 9? Mine says, oh, Lauren, so yours. Okay, so Emma and Lauren, Cassio's simplify radicals, which is awesome in an algebra class, but it sucks for this class. So same thing, when you do your square root of 14, hit that button that says SD, and it should change it to a decimal for you. Let me know if it works. And that, yeah, it's cumbersome. Oh, Emma's, yours didn't work? Okay, I'm going to have to look at yours separately. If you were in an algebra class, you would be thrilled, but you're not, so we want decimals. Okay. So since 14 is technically closer to 16, what my math lab is going to say is that the decimal number should be closer to 4. Because 14 is closer to 16, so the root would be closer to 4. But can't you just round that and see 3.7 is closer to 4? So don't get too bogged down in these, basically, is what I'm trying to say. Don't go down the My Math Lab rabbit hole on these. Stick to your calculator. And then My Math Lab is going to have you do guess and check to find it. So it's literally going to have you multiply a whole bunch of decimals, which you'll just use your calculator and see which one is it closest to. And then you'll see it's closest to the 3.7 times 3.7. But just use your calculator, basically, is what I want to say on this. So use calculator. You'll be allowed to do that if this comes up on a final. Just use your calculator. But let's just practice putting these in. So 3.9 times 3.9. Yeah, 15.21. Good. So that's way off. That's way higher than 14. 3.8 times 3.8. 14.44. Okay, so that's kind of close to 14. 3.7 times 3.7. 13.69. Ooh, and then that gets kind of tricky. Which one of those is it closest to? So this one is how close? I don't know. Let's actually find. This is 0.4. Oops. Oh, I can't erase. If I did that number, if you really can't tell which one's closest and took 14 away, it'd be 0.44 away. And then if I took 14 and 13.69 to see how far apart they are, remember subtraction tells you how far apart two numbers are. Those are only 0.31 away. So technically this one's closer. Because when I compared when I subtracted 14 from the first decimal number and I subtracted 14 with the second one, there was less difference between 14 and the 13.69. Anyway, but just use your calculator. And if you're struggling with those on MyMathLab, just don't go down the rabbit hole. Email me and we can talk about it, okay? Don't go down the help tool rabbit hole on these. So which one is closest? It would be the 13.69. But you would just, oh, sorry, not 13.69. Sorry, the 3.7. 3.7 times 3.7. Remember, squaring and square roots undo each other. So if you had 3.7 squared, it undoes a square root. So like I said, the next class is not algebra based. If you're going to statistics, it's not algebra based. If you're going to contemporary math, 1332, it's not algebra based. So you really don't need to know what a square root is. It's way too complicated to cover in like one day. So just use your calculator. And if you're really stuck on MyMathLab, email me and we can talk through it, okay? Oh, Emma figured it out. Shift, really? Okay, that's so weird, Casio. I'm glad you figured it out, though. Okay. So I want you to go ahead, and I'm going to be quiet for a second, and I want you to think about which symbol belongs between these numbers, because it can throw students off sometimes. There you go. Yeah, this one, so it should be the less than symbol. And this one isn't that bad because I see I have 89 cents. I always think of money. I have 89 cents over here. And then I have 89 cents plus some extra. I have 89 cents plus some extra. So it makes sense that I would put the less than symbol there. But I'm going to put a couple more up here just for you to think about that are a little bit trickier. So think about comparing these two numbers. What symbol would you use to compare those? Anyone want to be brave and type it down? Got a less than symbol? Anyone else vote for less than? Got another vote for less than? Less than's correct. Less than's correct. Students see 203 and they're like, oh, that's way bigger than 24. 203 is way bigger. But think about it in terms of money. This would only be 20 cents plus a little bit of extra. And this would be 24 cents. Oops. Hold on. Oh. Need to get this plugged in. Hold on real quick. There it goes. Okay. My I've fried the battery in my tablet, so I have to have it plugged in and my cord got loose. Yeah, so think about it in terms of money and then you won't get confused. If you always think about decimals in terms of money, you will not get confused. Okay, we have one more problem to do together and then I'm going to break us out into groups here in a minute. One more problem. And this one gets tricky. Okay. And I'm talking about this problem because I've seen it on the final so many times. Whoever writes the final just loves this problem. Now, have I seen your final yet? No. Well, do I know if it's going to be on there? No. But so many times I've seen it on there. So let's take a look at it. It asks to write a decimal that's somewhere between 0.32 and 0.321. To write any decimal in the whole world that you want, as long as it's between those two numbers. Well, the first thing you might do is put a 0 on the back of this one so that you're looking at 320 and 321. But still, it's hard to think of a decimal that's between those numbers, right? It'd be like 320 and a half or something between 320 and 321. But you can't write this decimal number 3 20 and a half or something. Like you can't write that as a decimal number. So you have to think of something different. Anyone have an idea what I could do there? Ooh, that's right. You can add more zeros. Okay, so we have a rule with decimal numbers. It says I can add as many zeros as I want to the end. So if I'm going to add a 0 to each of these. So now I'm comparing 3,200 to 3,210. So there's lots of numbers between there, right? So if you have 3,200, you could do 3,201, 3,202, 3,203, 4, 5, 6, 7, 8, all the way till you get to 3,210. And you can pick any of those in decimal form as a number between those two decimals. So just remind yourself, you can add as many zeros to the end of a decimal number as you want. So we can add zeros at the end of a decimal number. And it might help you compare numbers or think about them in a different way if you add those zeros. Okay, y'all. So I'm going to switch over to my app real quick so we can talk about a little bit of calculator stuff, and then I'm going to put you in groups. So give me 1 second here. Oh, any questions about the numbers between those two since I've seen it on the final so many times? Does anyone need clarification or to see another example? Do you want me to give another example so y'all can see if you really understand it? Yeah, let me do another example here. Let's see. Let's do this one. So, and I just want you to, I'm going to say, think for a second and then type it on the screen. Find a number between 0.05 and 0.06. Decimal number between those. Okay, go ahead and type them on the screen. What are you thinking? So Emma suggested one. Emma wrote 0.051. Anyone else want to make a guess? Ooh, 0.055. Yeah, both of those are right because I could add more zeros to the end here. And then you're just trying to think of a number between 50 and 60. See how that helps you think about it a little bit? Yeah, is 51 between them? Yep. Is 55 between them? Yes. Is 52 like Corey just suggested in the chat? Yes. So there'll be lots of right answers that my math lab will accept. And it was that trick of just adding more zeros onto the end there. And it doesn't have to be like halfway between. So 0.55 is halfway between, but as long as it's between there, you're going to be safe. Okay, cool. Let me pull up our notes real quick. Oops. I'm pulling them up in my app. Let me find where we are. So these are the notes if you printed them out. Oh, in the notes, just heads up, there's like a whole page on how to add, subtract, multiply, and divide decimals by hand. But do you have to know how to do it by hand? Nope. You're just going to use the calculator. So that page is just there for your information. You might have siblings or kids or someone that needs to know it someday. So you can look at it if you want, but you don't need to know it by hand. Okay. But moving on from that. Okay, get your calculator out if you don't have a calculator yet. Because this is all calculator that's about to happen here. And I know everyone's calculator is a little bit different. But before we do our order of operations, we have to know how to use our calculator because it's going to add, subtract, multiply, and divide for us. It's going to change decimals to fractions and vice versa. So you have to remind yourself, what operation does the fraction mean? It represents division. So when you have a top number over a bottom number, you can put that in your calculator as top divided by bottom. So if you're being asked to change a proper fraction into a decimal, you literally just do 3 divided by 5 on your calculator. Or you can do fancier buttons, right? You can enter it as a fraction and do the F to D button. If you have that F to D button, or you have the S to D, whatever it is on your calculator, if you have that button, you can do that. But just straight up divide and get your decimal. I thought I heard a chime. No? Okay. Oh, yeah, there it is. Okay. So I'm just going to write these decimals down here, and then I'm going to be quiet for a second, and you can just raise your hand if you have a question. If you're not getting them right, just let me know. So try these however you do it on your own individual calculator. Okay, are there any questions on any of these? Show me a status. Were you getting them right on your calculator? Okay, no questions. Cool. So you should be okay going back and forth on MyMathLab, and write yourself a little note that, when you enter your question, your answer in MyMathLab, read the fine print. It'll say round to something, or it'll say write your answer as a something. Make sure you're reading that fine print under the answer box. So you'll know, am I supposed to put a decimal in? Am I supposed to put a fraction? Am I supposed to round it? Like all of that fine print. Make sure you're reading it so you'll know how to enter your answers. Let's do one more before I put you into some groups here. Okay. Let's do number 9. This one's pretty easy. You just change them all to decimals, but let's look at number 9 because it's another one about being between. And remember, it comes up on the final a lot. So write a decimal that's between those two numbers. So type it on the screen whenever you're ready. Find a decimal number that's between those two fractions. So you'll have to change these both to decimals on your calculator, however you see fit, and then find a decimal number between those numbers. And you can type them anywhere on the screen. Oh, wait, I just realized you can't type on the screen Poop. I'm not in my... We'll throw it in the chat. What's a decimal number between those two? Uh, 0.7 would be a little bit too high, Lauren. So just to show you, if I add zeros here on the end, I'm comparing like 60 cents to like 66 and a little bit more cents. So thinking about it as money might help. What's a dollar amount between 60 cents and about 66 cents? And you can pick any dollar amount that would be between those money values there. So maybe you could say, I don't know, like 61 cent. Oh, don't put the dollar sign. Oops. That was just me. Oops. Yeah, 61 cents, 62, 63. You could even do like 0.615 if you wanted to. It just has to be between 60 cents and 66 cents. They're tricky, right? Yeah, these are tricky. Like, especially since you're going to be doing like rounding. And then it's like, what? You want me to think between things? Yeah, it's really tricky. And you're going to get, there's several of those on the My Math Lab, as I remember. So you just have to slow your brain down to like read, what is it asking me to find? You know, really slow your brain down there. Okay. So I'm going to put us into groups. I know this is a long class, so if you need to take a little like mini break or something, feel free to take a break. But I'm going to break us out into groups. And in your groups, I'm going to have y'all work through some order of operations. So it's the same PEMDAS. It's just now you're typing decimals in your calculator. That's the only difference. So, you know, you can just see, you know, give everyone in your group some time to work and then type your answers on the screen and see if they're matching. If everyone got it correct, great, move on. If not, call me over. You can unmute and talk. And then there's just formulas, just like you've been doing. But the numbers to plug in are going to be decimals. And sometimes the formulas will have fractions and you're plugging in decimals and it can get tricky. But here's the deal. In this homework, in the day 6 homework, since it's the decimals day, they're probably going to have you in fine print say like, write the answer as a decimal. So it'll say write as decimal to the nearest decimal to nearest whatever. So make sure you're reading like how to round your answer. So just be really careful with that. Okay. Yeah, and there's quite a few of the formula ones for y'all to practice. And then we'll come back together to do the equations. So in your group, I just want you to work the PEMDAS and the formulas. Okay? So when you get in your group, say hi, and then I'll share the PDF with y'all to write on. Okay, so y'all, this is our last breakout group. Isn't that crazy? Last breakout. We might do breakout groups on Tuesday, but this is the last official breakout group. Okay. Here we go. Okay, you're going to your breakout groups. I'll be hopping in, or just raise your hand and I'll come see you guys. But it says the line graph shows the relationship between air temperature and altitude. Now, this is what's tricky for me. Like, what are these numbers representing here? It's representing altitude in feet. But what threw a lot of students off, I think, is that the title up here, this is the title of the graph. But see how the title's running horizontal and that line is running horizontally? It's like, I think some people saw that as air temperature. So I'm just going to mark that out. The horizontal numbers are your altitude. These vertical numbers here are your temperatures. So these vertical numbers, those are your temperatures. So almost every single person got the first thing right. The general trend of the graph shows that as the altitude increases, so as my altitude is getting bigger, so at altitude of 5,000 feet, my temperature is up here at 40 degrees, right? So at 5,000 feet, my temperature is 40 degrees Fahrenheit. And then at 10,000 feet, it drops to a little bit under 20 degrees Fahrenheit, right? So at 10,000 feet, my temperature drops to like, I don't know, 18 degrees Fahrenheit. And then, right here at 15,000 feet, so this would be 15,000. See how it's just like a little below zero? A little bit below zero. So like at 15,000 feet, I'm just a little below zero. So like maybe, I don't know, maybe -5 degrees Fahrenheit. And then at 20,000 feet, I'm way down here. So 20,000 feet, I'm way down here at -20. If I follow it over there. Okay. So like -20 degrees Fahrenheit. So I can see that as my altitudes are getting bigger and bigger and bigger, so as my altitudes increase, the temperatures are getting smaller and smaller and smaller, right? So the temperatures are decreasing. So almost everyone got that right. It's this next part that got students tripped up here. It says the altitude is about what? So what yellow highlighted region? What feet where the temperature is -10? So -10 I can see on here is going to be somewhere between 15,000 feet and 20,000 feet, but closer to this -20 than it is to the negative, well, maybe closer to the -5. I don't know, but somewhere between there, right? So as long as you typed any number between 15,000 and 20,000, it counted it right. So you could type in 16,000 feet and it would count it right. You could type in 17,000 feet and it would count it right. 18,000, it counted it right. 19,000, it counted it right. But if you typed in 15,000, it counted it wrong. Because at 15,000, it was just like a little bit below. If you typed in 20,000, it counted it wrong. So 20,000, I can read exactly off the graph. It was like somewhere like -10 degrees right here. If I backtracked it on my chart, it'd be like between 15 and 20. So you had to pick a number between 15 and 20. You couldn't type in 15 and you couldn't type in 20. So I don't know. Show me a status. How do you feel on that explanation about why it can't be 15 and why it can't be 20? Because I think the most common answer was 15,000 feet. Feeling okay? Are there any questions on why it's not 15,000? Since I tried to type up feedback, but since so many people missed it, it is tricky. Yeah, I know. And this graph was just really yucky to read. So hopefully they'll put a nicer one on the test. But I thought, gosh, if they really they liked that question enough to put it on this practice test, so that might show up on the final. And I saw one similar to it in the review. So I was like, ooh, I better go over that since half the class missed it. I wanted to really make sure we talked about that. So there is a similar one in your review. So if you're still like, I don't know if I really understood that, you'll have a chance to try it in your review. And if you're still like iffy on it, you can just shoot me an email. We can talk about it. I can even make a video solution for that particular one since I knew a lot of students struggled. Let me write that on my to-do list. But don't watch the video until you've tried it on your own, right? But so I'm going to look at a video solution to post for this problem in the review. Okay. Yeah, so sorry, that was totally random, but I meant to do it at the beginning of class and totally forgot. Okay. So back to what we're doing today. We just have one page of notes left, and it's solving equations. But since I wasn't here the day y'all learned solving equations, I wanted to make sure we did that together, just in case you had a question about it. So let me reshare that page. Oh my gosh, Alejandro, your picture of the frog it's like, I love it. It's cracking me up. Okay, sorry, I just saw it really big on my screen. Let me pull this back up. So we are here. No. We are, yes? Oh, yes, here we are. Okay. Okay. Blurry. Okay. Oops. Hold on. My app. Give it a second. I think this is where all of our brains are right now. Okay. So I'm pretty sure that y'all could solve 1 and 2 no problem. It's a one-step equation. And since we only have a few minutes of class time left, I'll come back to those if we have more time in class. They'll be written up in the answer key. I just want to talk more about two-step equations because that's more likely, where students are going to struggle. So I want to work question 4 with y'all, 4, 5, and 6. And like I said, if we have time, I'll go back and do some other ones. So I'm going to be quiet for a second, for about 1 minute, and let you try to solve this, and then we'll see how you do. So be quiet, and no one type their answer in the chat. I want people to have a chance to try it. Okay, so Lauren said 10. Does anyone agree with that? I haven't done it yet. Anyone else get 10? Corey got 10. Anyone else? Does anyone need to see this one worked out? Well, I'm going to show you the check part because on your final, you will be required to check. There will be points assigned to solving the equation, and there will be points assigned to checking. So let's see if Corey and Lauren are right. I'm going to check this one. So this is not solving, this is checking. So to get your points for checking, this is what I need to see. I need to see you rewrite the equation. Okay, so you rewrite the equation. And then if you really think your solution is m is 10, I need to see that solution plugged into the equation. So wherever there was an m, you're going to replace it with a 10. So 3.1 side by side with the m means multiply, plus 2.6. And then I like to put a question mark above my equal sign when I'm checking. So after I've plugged my solution in, I put that question mark because I don't really know if it's true or not. I could have messed up and gotten the wrong solution, right? So that question mark is like, is it really true? I don't know. Now I'm going to follow PEMDAS. Well, to be honest, at this point, all I need to see is that you plugged it in. So if I can see that you plugged in this 10 here, then you can just straight up plug all this into your calculator because your calculator can do it for you, right? But technically, order of operations says we would multiply first and then add. So let's do that. So if I multiply, I get 31. And if I add 2.6, that does indeed give me a 33.6. So they equal each other. And then once I see they equal, I put like a little check there. So you will have to check on your test. So make sure when you're doing your review, if it says solve and check, go do those extra checking steps because points will be assigned to them. Okay, so I did want to talk about number 5 because it is a doozy. It is a doozy. Number 6 isn't that bad. Number 5, whew. Okay, so let's look at it. It says the following formula gives the relationship between capital C, which is degrees Celsius, and capital F, which is degrees Fahrenheit. Then we're asked to find the Fahrenheit temperature. So find the Fahrenheit temperature. That means we're trying to find F that's equivalent to that Celsius temperature. Yeah, this question is really confusing. But I think I saw something very similar on the review. So I was like, ooh, they like this one. Okay, so we're being asked to find F that's equivalent to this Celsius temperature. So we know the Celsius temperature. So when I rewrite the temperature, 36.5, but my variable staying trapped within a fraction that has a decimal, right? So it's a lot of stuff happening. So we're just going to go through the steps of how we solve equations. So step 1, you locate the variable. So locate variable, which we already did, right? We said, oh, our variable is stuck up here. Okay, step 2, you ask yourself what happened to it. So step 2, so according to PEMDAS, what happened? What's happening to F? According to PEMDAS, what's happening to F? Well, PEMDAS says you have to do parentheses first, right? You have to do parentheses first. So these parentheses are happening first. So the very first thing that's happening is that we're subtracting 32. And then we'll do our P, right? And then after that, there's no exponents. Then I would multiply or divide next. Then I would multiply or divide. And there is division by 1.8. That fraction bar means to divide. So the second thing that's happening is that I'm going to divide by 1.8. And then step 3 is you just reverse all that. You reverse it or you undo all that. It's like solving is doing PEMDAS backwards. So when I go to solve this equation, I need to start by getting rid of dividing by 8. So the first thing we're going to do to solve is we're going to multiply. Multiply by 1.8. If I want to get rid of dividing by 1.8, I need to multiply by 1.8. So I'm going to multiply this side by 1.8. So I have to multiply this side by 1.8. So see how that multiplying is going to get rid of the dividing? So it gets rid of the fraction bar. That's what the multiplying does. And the 1.8 cancels out the 1.8. So put this in your calculator. And I got 65.7. And I'm still left with everything in the numerator. But now I don't really need those parentheses there. I didn't really need them in the first place because it's assumed it's trapped up there. Okay. So we got rid of the division. Now, and then the next thing I have to do is get rid of the subtraction. So second, how do we undo or how do you reverse subtraction? You're going to add 32 to reverse that. Yeah, so just add 32 on both sides. That'll go to 0 and leave me F plus 0, which is just F. And on this side, when we add that together, that's going to give us a 97.7. Yeah, so how are y'all feeling on that one? Show me a status. How did you feel about that? Better? Okay. It's really tricky, but just slow your brain down. And oh, Corey's sad about it. You just have to slow your brain down and ask yourself what's happening first, what's happening second, and then undo those in the opposite order. Solving is just working backwards. It's undoing everything. Let me give it, since I'm pretty sure everyone can do number 6, with the rest of our class time, we're going to solve another one like 5. So let me share a whiteboard. Let's solve another one like 5. So I want you to solve, oops. I'm just making something up here. Ooh, what do I want to do? I want to do Oops. Oh, I forgot that erases everything. I'm just going to plug numbers in already so we can see here. Let's do... Oh. Yeah, let's make this pretty. Let's make this 60. I'm trying to make up a problem where the numbers will be pretty. Okay, so that's a 60, and we're dividing by 20. Okay, I'm going to give you a second to try to solve this, to see what you would get. Oh, poop, it's still a decimal number. And when you get an answer, type it in the chat. I'm just curious what you're getting on this. Has anyone gotten an answer that's brave enough to say what they think it is? It's ugly. That's why I said round to the 10th. Apparently, my mental math was not working out there. Well, what I'm getting is this. See if anyone got this. I'm getting 396.7 when I rounded. Eek. Did anyone else get that? This is why I don't make up problems on the fly. Okay, well, let's see how I got that. Oh, you got it, Corey. Yay. Did anyone else get it? Oh, well, Mireya got it. Cassandra, no, but that's okay. It was really tricky. I didn't mean it to be this ugly. Yeah, let's show. Yeah, let's see how we do this. Okay, so step 1 is you locate your variable, right? It's right here. It's an X. Step 2, list everything that happened to it. Okay, so I'm going to come over here and list what happened according to PEMDAS. Well, according to PEMDAS, according to PEMDAS, I'm supposed to do parentheses first, but remember that's any kind of group. Parentheses or any kind of group. Since the 3x plus 10 is in the parentheses, it's technically grouped together. So what's happening first in that parentheses? Well, the x is getting multiplied by 3, and then it gets added by 10. According to PEMDAS, if I'm looking inside those parentheses, I have to multiply before I add. So the first thing that's happening is I'm going to multiply by 3. Then I need to add 10.